Okay, so let's start with the ER diagram now. So figure 5.2 on your slide here show the there are actually two diagrams. One is the diagram, it looked like some sort of like a I don't know, honeycomb tree or some sort, or fishbone tree on the left, and the other one is this blue entity on the right. We talked about this already. The blue entity on the right will be the notation, most likely like an extended ER diagram, but it will also be used in the Crowfoot notation. The ER diagram on the left is the most original form of the Dr. Peter Chan's ER diagram. He drew this using a very old word processor software in his dissertation. And the notation here is that the concept called the entity is represented by a rectangle, and the attribute will be represented by the oval shape surrounding the rectangle. The so-called the identifier, and in the physical database we'll call this as primary key, is identified by the underlined attribute in the so the identifier is the underlined attribute here. In this case, will be employee number, right? So in the same notation, you can see that the employee number is putting on the upper part of this rectangle in a more like a dark blue color sort of a field here, and to represent the identifiers or the primary key later in the physical world. So this is very straightforward, and once you read this visually, it will tell you what are the required columns and information you need to keep about this particular entity. Very simple. So if you in the process of system development, from data's perspective, is now you start to think about before you design anything. You think about your domain. Domain means the problem you try to solve. If you are solving with a customer relationship management problem, for example, you start to think about, okay, in customer relationship management, what are these entities I try to keep track of? Employee, yes. I want to keep track of customer, of course. I want to keep track of the sales every time I make sales. I want to keep track of the product they purchase. So the product will be. So you keep thinking of the problem or the entity in that domain. That is the process of ER diagram, right? So very easily you can recognize without trouble by reading the ER diagram. So, and it is powerful because even without training, you can understand as a regular person what they are. That was actually one of the purpose, communicating the idea of required data to a person without information training. So I keep using the term identifier instead of a primary key because at a conceptual level, we are doing conceptual design. You don't want to mix up with how it will be implemented. So we try to change the terminology to identifier. But over time in practice, you still hear people or me even talking about, okay, this underline is your primary key, right? So it's identifier later will be converted into primary key. And you can also have composite identifier, just like you can have composite primary key. And all these have implication later on when you build a database in a database management system. And entity depends on what level of the discussion you are talking to people to. Sometimes you want to talk to people in a higher level, so you don't want to describe the detail of in terms of the attribute for the entity. You can simply using the short notation or simple notation. So in this example, you see B and C are simple notation of entity, but A represent the full notation or the correct notation of entity. When we work on exercise in our assignment, you will be using slightly different. I'll share with you, but you can use the one we see on the left will be good enough. But it's not the best way to represent the entity. Just telling you there are many different forms. By the way, connecting to the UML or System Estimate Design class, this variation, right? These different way of representing the same concept. In this case, all three of them are employees. Some of them are simpler, and you can even draw a little like stick figure to represent what is in the employee. And these variation way of representing the same concept, as long as they represent the same thing, they are all acceptable from the modeling, from the draw diagram perspective. And that terminology we use in UML is called a stereotype. So you create stereotype so that you can create multiple mutation of the same concept. And in object-oriented world, we call that multiplicity. No, I'm sorry, not multiplicity. Multimorphism concept. So you morph, you morph multiple times. Same concept can be reused and reused again. So so that morph is actually a very interesting word when computer science world select to use to describe different. It look different, but they actually represent the same thing, right? So, and once you have entity defined, their attribute defined very well, the next thing to do is to identify relationship among entity. And relationship is important. It's actually the relationship defined or be defined by the business rules or business process you try to create. So whenever two entity has a business encounter, exchange information or request of service of some kind, and say for example, if you have a customer go to an employee says, "I want to buy something," so this exchange between customer and employee create a relationship between, and that is a business relationship. So if two entities does not talk to each other, it means that there's no relationship, right? So and so the relationship is defined in the business domain, that particular environment, not defined by our human perception, right? So using that concept, there we can say you go to Walmart, right? You talk to the clerk, the person or employee associate working in Walmart, and so the customer has a relationship with the associate, right? But do you have association or relationship as a customer, as a Walmart customer, with say the CEO of Walmart or the founder of Walmart, Sam Walton? She died. I mean, he died already, but so. Um, it depends, right? You can argue, yeah, I have a relationship with the uh, the CEO of Walmart. Because he created the company, and I shop in the company. In some way, we are related. But have you ever talked to the CEO of the Walmart Corporation? Probably not. So there's no relationship, right? So relationship is defined by your business relationship, not by our human experience. That's putting that, or human perception. Right. So the entity, and you define relationship, and you have entity relationship diagram. Each relationship is defined by how they relate to each other than the meaning of relationship, but also the degree of relationship. It could be the one group of people related to each other, student related to student, or two group of people relating to each other, professor related to student, or three group of people related to each other, and professor, student, and advisor. Right, so three group talk to each other. So each one of this different type of relationship generate the three different type of, actually more than three different type. You can have higher degree of relationship. It's called a unary relationship, binary relationship, and ternary relationship, right? You can also have quaternary. Is that how you create a quaternary relationship? Four group together, right? But usually the recommendation for database design is do not go over three degree. Go over three degree is almost like in the physical world. You go over more than three dimension of the physical description. Our human brain will be very difficult to handle higher degree relationship. So in design database, the recommendation is keep as low as possible the degree of relationship you try to design. And typically we recommend keep it under binary. Don't even try to use ternary, right? Because why? Because the database management system we have now commercially can only implement binary relationship. No database can implement ternary relationship. So if you have ternary design, you have to somehow come up with a different way of describing or converting conceptual design into physical design. So once you have a relationship, entity and relationship and the degree of relationship, now we can start building ER diagram now. This notation you are seeing now is different from the previous several notation now. The entity notation is the same. You still see the rectangle, three-dimensional shadowed notation for entity, but there is one special notation show up in a, you can call them a diamond shape or some sort of, yeah, it's probably best to talk this as a diamond in the middle. Is it diamond or yeah, so the diamond actually represent the name of the relationship, right? So yeah, we in a traditional ER diagram we call this name of the notation. In this case, the thing between employee and skill is a relationship of qualification. The relationship among the ternary relationship between client, architect, and project is the assignment. So the project assignment is the concept linking client and architect together in a private house building project, right? So this is actually the still the original notation of ER diagram. And one of the notes your textbook have here is the entity will usually be put into a table, and relationship is described as in a line in ER diagram, but it will be converted into a foreign key in implementation. But during the discussion of the ER diagram, we do not need to concern about foreign key. And after you specify the type of relationship or degree of relationship and entity and attribute, next thing to do in specify the relationship is to define cardinality. Cardinality is a mapping between one group to the other. So there are two terms. One is called maximum cardinality. The other is called minimum cardinality. And I'll use example to explain that because this sentence can be very confusing. In the UML world, in object-oriented world, cardinality is but in object-oriented world, people do not use cardinality. They use another term called multiplicity, the word I used earlier, but it's not multimorphism. Multiplicity is the word used in UML, object-oriented world. And here, but they are essentially the same thing conceptually. Right. So let's take a look at what is cardinality. Cardinality is the one-to-one, one-to-many, many-to-many relationship between two entities. And so some example here, one-to-one, one employee, one badge. One employee, there's a thing say n multiple computer, right? One to many. One employee, many computer. That's how you read it. So many in the entity relationship, we use N or M to represent, right? N or M represent multiple. You choose each one of them. Depends on which. The first one usually is N. The second one is M. So in the many-to-many, we have N and M to represent a many-to-many relationship. But this traditional way of representing the well, actually, this is not traditional way, right? This is already extended way of entity relationship. Traditional way, you will see this oval shape in representing attribute. You don't see oval shape here already. So this is the extended way. And this example on the slide here, the three examples, does not have the concept of minimal and maximum cardinality. It has the one-to-one, one-to-many, many-to-many concept, but the minimal and maximum are not explained. Let's continue to see some example of minimal and maximum. We'll come back to this description of thing here. But this is the description about the minimal and maximum. In this case, the minimal to be described first. And the best way to understand minimal and maximum is you go from one side, and in the object-oriented world, we call this role play. So you have to imagine in design process to imagine yourself as one of the entity object here, or entity instance here. So in example A, you have to assume yourself in this business environment, assume yourself as one employee in the company. So if you are an employee in the company, the question is, how many badge do you have, or does the company allow you to have, right? And in this case, that it says, so if you stand, right? So in the physical classroom, usually we'll play the role called role play. And this method, by the way, let me put a little term here to tell you what we usually refers to in a typical word. It's called CRC. Right. This is called a CRC method. Right. Very quickly, just a quick poll. Any one of you remember or know what CRC stands for? What? In computers, this is original coming from computer science. It's also in object-oriented programming. It's a method. It's actually a method. Unfortunately, no. It's called collaboration responsibility card or something along the line. So R is responsibility. So we're looking at the responsibility of each object and try to assign attribute. But anyway, so this is the CRC role-playing method. So basically what we are doing here is this. You look at the diagram from one side. So you stand on one side. So if I'm an employee, what is the minimum number of the badge I should have? Can I be an employee without any badge? Or do I work in the company? I have to have one badge. So that is a business question we ask. Right. So if your company is very well established, everybody need to have an employee card or badge or some sort. You're saying, oh, every employee need to have a badge, otherwise you cannot enter the company. Right. Then you have a minimal requirement, minimal cardinality for badge. So on the right hand side, you see the badge. I'm moving my cursor now, or actually drawing something here, or put a stamp here. Actually, no stamp here. I can draw something here. So this, I just pointing my cursor here will be good enough. This side is a bar there. That bar represents minimum 1. And 1 means required. So in this case, we're saying that every employee require a badge. Right? The other side is more difficult to understand, but you can still play a role there. Assume yourself is the badge, and try to look at the employees. Well, if I'm the object badge, I'm in this company. I'm this little player, an equipment or something that need to be used in the company. So if I'm a badge, do I need to belong to an employee or not? Can I be a blank badge and still be called a badge? Right? Then if your answer is yes, every badge is belonging to an employee, then the other side is also 1. So in this company that we have, every employee need to have a badge. Every badge belongs to an employee, at least 1 employee. Right? So that's minimal cardinality. But is that particular cardinality rule correct or not, or good or not? Is that worse or better? That's a design problem. Right? Let me explain it a little bit. Imagine yourself again. You go to UIS, and if UIS someday says, okay, every student, every faculty member, everybody going to the university need to show your student ID, like you need to wear a badge. You're saying, what about if I invite a guest, my friends coming to campus? How do I do with them? The university probably say, oh, you have to apply for the visitor pass, right? If that is the case, that the badge will no longer belong to the employee or be assigned to employee, will be assigned to the visitor. And when the badge is assigned to a visitor, then you violate your rule here. Because in this diagram, you're saying the badge have to be minimally assigned to an employee, right? So, but there are more business rule or management rule we can discuss. But basically, I think my point here is the minimal cardinality or maximum cardinality or the cardinality in general. How do you define them? It depends on how you design your company or design your business process operation, right? And your business operation determines what is the best. It's not what your professor thinks it should be the best, or some philosopher think it should be the best. It's the designer, it's your business situation. So in different business operation, the cardinality will be different between two entities. Right. So I think that's my point. The other example is not showing up on your screen here. Is think about always that I always use this because we are in the university. Think about a professor in a course. What is the cardinality between professor and course? Is that a one-to-many or one-to-one or many-to-many? One professor teach many class, one course is teach by many professor, and one course have to be teach by one professor, right? That become a great question, right? Because it depends on which school it goes to. It depends on how large and how small school are. It has a different answer, right? So cardinality is always a question about how you design. And one last comment about cardinality, one-to-one, one-to-many, or many-to-many, is 95 to 99% of the relationship in the real world are always many-to-many, unfortunately. Right, so that comments I'll explain probably again one more time in the future. Okay, part B that you see minimal, zero, zero, sometimes we call them optional. So you look at employee in this company, in this situation, employee is related to computer. So does employee need to have computer? The answer is no. But can employee have computer? The answer is yes, because employee is related to computer. So every employee come to our company, we may assign a computer, or minimally optional. Minimal optional means minimal zero. A circle there represent optional. So employee can have zero computer. Computer can belong to zero employee. So that's how you look at it. Similarly, employee can need to have at least one skill. A skill does not need necessarily to be possessed by any employee in part C of our example. Right? So this is minimal cardinality. Using the same concept, we have minimal, we have maximum cardinality. So extend from minimal to maxima, that we have this example here that you have a department and employee. So we read from the employee side. Assume you are employee in the part B of this example, or part A. That's part A, part B. They are the same thing. Two different notation. Part A is the ER model notation. Part B is a Crowdfoot. We're going to be moving to Crowdfoot notation in our class after the slide or next. So in this relationship, if you are an employee, you think about, I work for this company, how many departments should I be assigned to? Right? Can I work for a company without being assigned for a department? Well, maybe not. Well, if you are going to be working at a company and you are a new employee, you are not assigned to any department yet. Maybe you don't have a department, right? So in this example is we define or design the business, the minimal department to be assigned to an employee is zero or optional. But maxima is one. So employee can belong to only one department. Employee cannot work for two departments. He or she can report only to one department boss, not two. Right? So that's the business rule here. But in real world, can we have an organization, an employee work for two departments, like in our university? Can a professor work for two departments? Well, the answer is yes. We have something called a joint employment or joint contract. An employee can be hired by, half time working for business school, the other half working for the provost office, right? So that's possible. So again, the maximum minimal cardinality depends on the business rule. So in this case, based on that training, we have the notation away. Well, if you look at employee and you stand on the employee side and look on the department, the notation close to employee, the first one associated with department, is the optional. So the inner notation is the minimal. The farther or the outer notation, in this case 1, is the maxima. So minimal option, maximum 1. So no department or one department is the rule. If you look at from the other side, assuming you are the department, which is an abstract concept, but you think about how many employees should be assigned to this department. I would, in this case, I would say if there to become a department, you have at least one employee. If you do not have any employee, it's not even be called employment in department. So looking from department toward employee, you see that minimum is a bar 1, and maximum is this 3 bar, more like a fork or a trident type of notation. That fork is something we call crowfoot notation or crowfoot here, and crowfoot represent many. So minimum 1 employee, maximum many employee right here. So 1 to many, many to many, 0 to many, or option to many now can be defined very well with the notation we have in here. Right. And once we learn this, you already ready to build your ER diagram. Now you only need experience and practice to survey a different type of design to come up with a better ER model. Now, there is also one small difference between the original ER model and the crowfoot version of the ER model. That is that you see that in part A, you have a solid line connecting or relating to entity. But in the crowfoot, you have a dashed line, and the dashed line will be explained in our chapter 6 discussion. So these are the notation: 1 to many, mandatory 1, mandatory many, option 1, option many, and how they represent in the crowfoot notation. And now you can try to practice and look at the notation from your textbook. And the dashed line we talked about earlier, right, leads to our next important concept. See, this line is dashed, right? Dash. The next important concept here is called the strong and weak entity. Strong entity usually refer to something that can stand by itself in the real world. It's a standalone, independent, but again, this is relatively speaking, is independent. So probably learn better from looking at the example. So building will be strong, apartment will be weak. Weak means that the weak entity usually exists, depend on the existence of a strong entity. So apartment cannot exist unless you have the building, right? So what other weak entity we can look at is what kind of entity is weak in the real world relationship. Say, for example, children and parents. Well, that's a bad example, but children cannot exist without the existence of parents. Right? So that's actually a very bad example. And try to think about something that is describing the weak entity better. And maybe machine and its part will be a good example. Or say a wheel will be weak compared to the car is strong. But wheel itself can be a strong entity as well. But weak and strong is relative, and we'll probably see more example. I failed to give you more better example, but I may try to stop there. And there is a good example here. Apartment cannot have an apartment sitting there by itself. It had to be inside of the building before you can call this an apartment. Right? And that same concept implement into logical model, we will call this an ID dependent entity. Without further confuse you, and I will stop our ER model here. And what we will do is you will be now given a ER diagram assignment next Monday, and you will start working on that assignment and try to, in the process, try to debate or try to think about what is the best way to represent the group of data you try to organize them, structure them together in a database, and we will continue after we see a few examples of those. And next lecture, we'll continue the ER diagram and see how ER diagram can be converted into a physical database.